four more examples for slices of circles. This next one right here is a segment of a circle. And so remember, a segment of a circle is going to involve getting the sector of the circle and subtracting off the area of the triangle right there. So area is going to be the arc measure out of 360 times pi r squared. That's the sector area, and we're going to subtract off that triangle. So we're going to subtract off the base times height divided by 2. So let's take a look at what we've got here. So we've got this 72-degree angle right here, which means that this remaining amount right here would have to be 108 degrees because this right here is a semicircle. This right here is a diameter, and therefore we've got 180 degrees around the outside of the semicircle, and 180 minus 72 gives us 108. So we had to do a little bit of work there, but 108 is the arc measure that we are going to use from here to here, so that is 108 degrees. 108 out of 360 times pi r squared, and if we look at the radius there, it is listed as the 10, so pi times 10 squared, and we're going to subtract off the area of the triangle. The base of that triangle right here is the length of the chord, which is 8 plus 8, or 16, so we're going to subtract that area triangle. So base times the height of that triangle is the 6, because that's the perpendicular distance between the base of the triangle and the vertex of the triangle. Base times height divided by 2. Okay, so plugging in all those numbers, let's simplify just a little bit here. So 108 out of 360, that would be 3/10 times, okay, 10 squared is 100, so 100 pi, minus 16 times 6 divided by 2, so that actually turns out to be 48 when it's all said and done there. Now if we're going to leave our answer in terms of pi, just like we did before, we're going to actually multiply this part right here, and so that right there, 3/10 times 100 ends up being 30 pi minus 48. So if you were going to leave your answer in terms of pi, that would be it, something like that, units squared. Notice that we don't have any specific units there. However, as a decimal, if we take 30 pi minus 48, that comes out to about 46.2 square units. All right, so there is our answer. Example number 2, or actually 4, is listed on the page here. We have another segment of a circle, and we have a couple other givens here. We've got 135 degrees is this arc measure. Now notice this central angle is congruent to this one over here, so that would mean that this other arc would be 135 degrees. So this arc right here is 135, and then this arc here is 135 degrees. And if we take 360 minus 135 minus 135, that actually leaves us with 90 degrees for the remaining arc over here. So that is the arc measure that we're going to use. That right there is 90 degrees, which means this central angle right here is 90 degrees. That actually is going to be kind of important, because if that central angle is 90 degrees, then this radius right here, 7 centimeters, and this radius right here, 7 centimeters, will actually end up being the base and the height of that triangle right there. Now notice in the previous problem we used the chord as the base. Well, that's fine. You can use this chord as the base if you knew that length, but then you would need this perpendicular height right here, which we don't have. We don't have the length of that chord or the height right here. However, this is a special situation here because it's a right triangle. And a right triangle, we know we can use one of the sides as the base of the triangle, and then the other perpendicular side as the height of that triangle. So the base and the height of the triangle right here, we can actually use the 7 and the 7. So that's a little tricky, but we figured it out. Good work. All right, so the area is going to be the sector of the circle. So arc measure out of 360 times pi r squared. minus the area of the triangle, so base times height divided by 2. All right, so now we have the arc measure is 90, so 90 out of 360 times pi r squared, and the radius is 7, so pi times 7 squared, minus our base times height. This is what we were talking about before. Base times height divided by 2. We can actually use both of the 7s as the base and the height of the triangle, so 7 times 7 divided by 2. So our area, reducing the fraction, 1/4, and that would be 49 pi, and 7 times 7 divided by 2, that would be 49 divided by 2, which is 24.5 right there. And once again, leaving it in terms of pi, we're going to multiply these two numbers here. And so 1/4 times 49, that doesn't end up being very nice, but we're going to have just 49/4 pi minus 24.5. And that would be, I guess, centimeters squared, square centimeters. That's a pretty ugly looking answer, but it is an exact answer, so we're happy about that. As a decimal, though, if you took that and did the subtraction, you would end up with about 14, even rounding to the 10th place. You would have rounded up to 14 square centimeters. So there is our answer in terms of pi and rounded. Right, our third problem here. Notice that this is an annulus problem, but it's half of an annulus. Half of an annulus. So if we could get the area of the entire annulus, then we would take it and divide it by 2, and we would get half of it. All right, so let's mark in what we have here. We've got 3 centimeters, which means that this is 3 centimeters over here, and the congruent markings also would indicate that this is 3 centimeters. So the radius of our large circle is actually going to be 6 centimeters, and the radius of our smaller circle is going to be this 3 centimeters right here. Okay, so that means the area for an annulus, remember, is pi times big R minus pi little r squared. So area is equal to the pi times the large radius, which is 6, so pi 6 squared minus pi times 3 squared. And remember, what we're really going to do at the end here, and you can maybe think about this, is we're going to divide this by 2 at the end because it is half of an annulus. So let's just keep that in mind as we go through this problem. In fact, maybe I'll just write it like this, divided by 2, because the area shaded is half of an annulus. So 36 pi minus 9 pi divided by 2. 36 pi minus 9 pi, so that would be equal to 27 pi divided by 2, which would be 13.5 pi, and that would be square centimeters. As a decimal, that is right about 42.4 square centimeters. All right, last example. All right, this is kind of a funny one, and it's going to involve a little bit of thinking here and a little bit of sketching in what we've got. But here's what I'd like to do. I'd like to draw this line straight across right here. And I want to think about what I've got. If I think about this area right here, which is half of the area of the circle, and notice what kind of goes into that, what these holes are right here. This little area right here, and this little area right here. So if I could subtract off those two semicircles from my green area, then I would have the shaded area left here. Well, not the shaded area that's right there, I guess, but the shaded area, like if I put this right here, that would leave me with the shaded area. So let's see what we can do here. That really is this semicircle, so this blue semicircle right here, minus the area of one red circle, because these two semicircles could be pieced together into one red circle. And so the area of that semicircle, that blue semicircle, minus the area of one red circle will leave me with this yellow region that is shaded. Okay, that's a little bit complicated, but I think we figured it out. So if I take the semicircle area, so pi times the well, let's call it the big R squared, and divide it by 2, because I want to get the area of a semicircle. And I'm going to then subtract off, and let's just color code here just so we can emphasize. We're going to subtract off the area of one small circle. So we're going to subtract off pi little r squared. And then that will leave us with the area that is in yellow here. So this particular slice is not necessarily one of the main regions that we talked about. So that just involves a little bit more thinking, and I think we figured it out. All right. So pi times big R squared. Okay, so what is the big radius here? This big radius, this distance right here, is going to be 5 plus 5. So we've got these little radii right here are 5 and 5. So 5 and 5, so that's 10. So the radius of the large circle is 10. So pi times 10 squared divided by 2. And minus the area of one small circle. Well, the small circle has a radius of 5. So pi times 5 squared. All right, so that gives us 100 pi divided by 2 minus pi times 25, or 25 pi. So that really is 50 pi minus 25 pi. And that gives us a final area of 25 pi square centimeters. And that is approximately equal to 78.5 square centimeters. I hope you followed that. If not, feel free to pause and rewind and take a look at that again. But this problem could be done in a few different ways, I think. That's how I saw it, and hopefully you got to the same final answer if you did it a different way.